So we want to look at types of electrical maintenance testing. As you can see on your screen, we have various types of electrical assets that we can carry out electrical maintenance tests on. Okay? So the first that we are going to look at is the insulation resistance test. Insulation resistance test, and the reason why we carry out this insulation resistance test, we are going to look at it. Okay? And which particular component of the asset that we are testing when we carry out insulation resistance test. Then we also look at power factor test. What are the differences between the power factor test? Okay, the insulation resistance test is a DC test. It could be high voltage DC test or low voltage DC test. Okay. Then the power factor test is an AC test. So we'll see the asset that we can deploy these two tests on later. But basically, both of them looks at the insulation of the asset. Okay. We also have the high pot test. It also looks at the insulation high potential test. So the insulation is actually subjected to a very high potential difference. Okay. To ascertain the functionality of the insulation. Then we have the winding or low resistance test. Okay, this one actually helps us to look at the windings of the electrical asset or the equipment. So we are going to look at the insulation resistance test now in a little details. Insulation resistance test. What is it? What are we testing when we carry out insulation resistance tests? Okay, and what should be our expectation from the test? How it is done? Okay. So, what is an insulation? What is an insulation? An insulation, simply put, is the act of separating two live parts. Okay, that is isolating them electrically so that they do not come in contact with each other. Basically, it is done to guide the flow of electricity through a predetermined path, that is through the conductor and through the conductor only, and through a particular conductor within the system. Okay. So, like what you can see, this is a conductor, and it is this conductor, this is the only active part in this cable. Okay, this is the part that carries the current. So this insulating, this part around the conductor is the insulator. Are we getting it? So this insulator, as you can see, we have insulators on each of the conductors. Okay. So these insulators actually helps to guide the flow of electricity through the conductors, okay, and not having to short circuit or to jump over to the other conductor. Okay, so this insulation, when you carry out insulation resistance test, maybe between this conductor, say line 1 and line 2, what you are actually testing is the dielectric strength of this insulator and this insulator that is covering these two conductors. Are we getting it? And that is the level to which those two insulators will be able to withstand the voltage that will be, or the pressure, the voltage that will be applied to this particular these two conductors. Okay. Maybe it is between this and this, it is this and this. Are we getting it? So that is the insulation, and that is what you are testing when you put a probe here. Okay, you put a probe here, and then you inject a predetermined level of voltage to get the insulation resistance reading. Are you getting it? So you do that to test that the insulation between these two conductors is still safe for use within the circuit, okay, and that there won't be any breakdown of insulation during usage, okay. Then in the equipment, as we will see later, you see that this is a transformer. These conductors, okay, they are isolated from one another, the three of them, and even within a leg, as we will see later, the primary winding and the secondary winding, they are actually isolated. They do not have connection with each other, okay. So when you are testing, carrying out insulation resistance test, it is that separation, okay, the level to which that separation will withstand voltage pressure. Are we getting it? So whenever you hear me say pressure, since we are discussing electricity, you know that I'm talking about voltage, okay. So electrical insulations. So apart from those wires and cables we saw in the last slide, the other electrical equipment or assets, they also have insulation. Like we said, insulation is to guide the flow of electricity through a predetermined path, okay, to your equipment and back to, from source to your equipment and back to source, okay. So insulations, you can find them in transformers. Like we said earlier, as you see here, this is the core, the transformer core. Are you getting it? This is the transformer core. And then you see that wrapping the transformer core is an insulation, that is a non-conducting material. The material that is, this conductivity is very, very, very poor, okay, simply because you do not want interaction between the live part and this core, which we usually have connection with the ground or earth. So this is an insulation, okay, on the core. So whatever you put on this insulation, I will not have any business with this core, okay. So as you can see, this is the low voltage winding. See it inside, okay, close to the core. This is the area that the core will fit into, okay. So the low voltage winding is usually close to the core. Then between the low voltage winding and the high voltage winding, you see that there is a separation, an insulator, and this is an insulation bar too, okay, between the low voltage winding and the high voltage winding, and there is a space between it, okay. Remember, this transformer is oil feed transformer, which means oil will go into these spaces, further improving the insulation between the primary and the secondary of the transformer. So when you carry out tests between primary, insulation resistance test between primary and secondary, what you are testing is the insulation of all this material, including that of the cable, the oil that fills the space between the primary and the secondary winding. That is what you are testing when you carry out insulation resistance test, or when you carry out even your power factor test, okay. You are testing the integrity of the oil and all of these insulating materials, okay. So this is the wound transformer windings finally, okay. So you see the primary winding and the secondary winding, remember from what we saw, they do not have interaction. So when you test the insulation between these two, you expect it to be high, to be very high, because they don't have any interaction. And also too, remember the core, okay, of the transformer was insulated before the laying of the first winding on the core. So you see that this winding will not have any business with the transformer core. Are you getting it? That is, none of the winding has business with ground, okay, of the transformer, as we will see later. So this is after the installation of all of the windings in transformer tank. So you see the various winding, the various winding of each of the faces. Okay, remember each of the legs, each of these three, they have both the primary and the secondary in them. Primary and secondary have no intentional connection; they are not connected together. Okay, so the output of the primary is taken to this low. Okay, the secondary now, because this is a step down transformer. The output of the secondary is taken to this low voltage bushings. Are you getting it? Then the output of the secondary primary is taken to these high voltage bushings. Okay. So now, when you want to carry out insulation resistance test or power factors test, as we'll see later, you will see that it depends on the connection. This three set of winding will be delta, as we'll see later. So they have connection. They are connected to. So this one will read to this and to this because they are connected internally, either star or delta. Then the primary windings is we have 4 terminals. Okay, it's usually if you have 4 terminals, that means it's star, as we'll see later. The common or the star point will now form the neutral. Okay. So now, if you are carrying out insulation resistance test, you place a probe here, any of the secondary terminal, okay, and any of the primary terminal. Remember, they don't have any connection. So when you test, you are testing the insulation of the materials that are separating the primary and the secondary inside the winding, including the oil that is filling the space between the primary and the secondary. So if there are any deterioration between, that is, the dielectric strength is deteriorating or going down, of course you will see it in your insulation resistance test. As we'll see later, the leakage current will increase and then the insulation will have dropped. Okay, so remember the yoke was also insulated, so the secondary winding does not have any business with the body of the transformer, okay, with the ground of the transformer. The secondary winding also does not have. Okay, so you can take insulation resistance test between the primary winding, okay, by taking on any of these bushings, any of these 3 bushings, okay, between here and the ground. Are we getting it? Or between the secondary winding, any of them, and the ground. Okay, that will give you the separation between each of these windings and the ground. Are we getting it? So when you are testing, that is exactly what you are testing. When you are carrying power factor test too, it's the same thing, because you are looking at the insulation between the secondary and the primary windings, and also between each of these windings and the ground. Okay.